Okay, perfect. I hope I'm audible to everyone. Good evening, everyone. My name is Chetan Singh Chauhan. I'm the current secretary of Kaziranga House, and I welcome you to this fifth session in this end-term revision series that we're conducting for all of you. This entire series has been planned and conducted by the Kaziranga House, and we're very happy to see all of you in such great numbers joining these sessions regularly. So first of all, I would like to thank you guys for joining these sessions regularly. And yeah, it will be recorded and it will be made available to all of you on Kaziranga YouTube channel. So you may review the session once again if you wish to. So this is the fifth session. This is a session for MLP, machine learning practices course. And good for us that the web admin of the Kaziranga house also happens to be the current MLPTA. So he has very graciously accepted the offer of conducting a session for machine learning practices for the end term revision. So please welcome Kshitish Maheshwari, um, the web admin of Kaziranga, as well as the current TA for machine learning practices course. Kshitish, are you there?
Yes, yes.
Okay, perfect. You may take over now. Just a small request to all of you before Kshitij takes over. Please make the session interactive. Ask him questions. If he asks you any questions, please respond to him. Be blunt. If you are not prepared for the end term exams, be blunt about it. If you have not watched a single lecture till now, be honest about it. Whatever topic you're not able to understand, Kshitish will put some emphasis on that topic and will try to elaborate on that topic so that it is clear to all of you. And yeah, let's make the session interactive. Shouldn't be a one-sided session, shouldn't be a boring one. So please keep note of that. And Chidish, you may take over now.
Yeah, thank you so much. Thank you so much, Chetan. So, good evening, everyone. Hope you all are doing well. So, let me share my screen also so that I could write something and show and discuss things. So, I hope my screen would be visible and good to see all of you here. So, just to quickly iterate over the syllabus, firstly, this course is basically having 12 weeks of content. And out of this 12 weeks of content, you will be having 11 weeks of content as part of your end term. And the week number 11 itself, 11th week, will be excluded. This is one important thing. And then for the remaining 11 weeks, which will be part of end term, you will be having equal distribution in the questions that you will see. So if I have to simply write down or tell you the content of which we are having in this course, the week 1 to 4 will contain information about pandas and basic data processing and manipulation, stuff like that. This week's will also include you or will also brief you about the available content or a refresher of stuff from the machine learning techniques course algorithms that specifically is in week 4. Then after these 4 weeks, week 5 to 7 will focus on regression, classification, and the evaluation metrics. So regression model, classification models, and evaluation metrics. Week number 9 specifically is unsupervised learning. And then week 8, week 10, and week 12 are the new contents which have been introduced in our course. So they will be having topics from image classification, text classification, recommendation system, and time series, a basic introduction to each of these topics. So for specifically these new contents, You should be the content is text, image, recommendation system, and time series. So for this new content, you should thoroughly go through the course portal videos and stuff like that, because this will ensure and will emphasize specifically on that portion, because this content is newly released and is relatively a new introduction or a basic introduction to these advanced topics which are part of machine learning. So let's sequentially move to each of these parts and maybe try to cover some important things, or I'll provide you with some important topics and information that could be useful for you to get an edge over your interim examination. Okay. So as mentioned, week 1 to 4 will be focusing on data part. It will include stuff from pandas. It will have your pandas profiling portion, like transformers, pipelines, and very stuff like that. Okay. Apart from that, week 4 will be a quick refresher over the machine learning models or the machine learning algorithms which we need to study in our course. So if I have to tell you about the week number 1, it will contain information about the stuff of pandas, like pandas data frames, pandas series, and then from these specific pandas data types, which are data frames and series, you will be having different sort of informations or possible methodologies from which questions can be asked. You might be asked questions from portions like conditional filtering, from indexing, from slicing, and what are your methods of filtering rows based on conditions? What are your attributes of group by, apply? How do you write functions? What are the operations that you can do on these things, and everything associated with it? After that, you will be having things related to pre-processing. So let's take some of the possible things which we can cover. Let me have some collab notebook with me so I can show you
Your
some content.
voice is your voice
Yes.
is not clear and not coming clearly.
Am I audible properly now? Okay, looks like I'm properly audible now. Okay, let's see if we could cover some probable concepts with the help of a collab notebook in which I can maybe show you a quick refresher of things. So yes, the resources that I'll be utilizing in this entire session, you can find each of those resources on the discourse forum. In the course portal or in the discourse forum of the specific course of machine learning practice, you can find a proper pinned post which is for the TA resources. And both me and my co-team, Mr. Pulkit, and we both have collaboratively worked on that specific post and created resources for your help only. So let's see some of the possible things that we could learn with these resources. Okay, let me share a collab notebook then. Okay, so what you can see is like a collab notebook in which we'll be seeing the stuff from pandas. And on this, what you can see is basically a dataset which is created. So this dataset is a dummy dataset which is created for a sales exercise. So the first thing which you can see on your screen is basically called a pandas data frame. This is the most basic structure which you can see for the pandas stuff. Okay. It is kind of a tabular structure in which you will be seeing rows and columns metrics, and then every possible point is basically populated with some sort of data. So for the available collab notebook or the available data frame, there could be two types of data as we can see, or we can say they are specifically the numerical and categorical. So this is the most basic stuff you should start with and understand what are the numerical and categorical data. The numerical would be including things like integer and float, whereas categorical will be having the object data types. Okay. So This is the building block or the starting point of the course, and this is all on this entire portion. The course eventually builds up. So what you're seeing on the screen is basically a data frame. And now let's move forward and what else we can see. So this is the attribute of head initially utilized for having the initial 5 columns. This is one important thing which comes up. So this specific thing called dot describe is an attribute associated with the data frame object. And what it helps you is with basic or in the simplified terms, I could say the descriptive statistics of the available numerical features. So this is one important thing which you should emphasize. Whatever you are seeing on the screen is the simple descriptive statistics which is present only for the numerical features. So a question could probably come from this portion, like you'll be having or provided with some columns in a data set, and out of those columns, some would be of the data type or numeric or number, and the others would be of data type of object or categorical stuff. So a trick question could be created at how many number of rows or number of columns you would be specifically seeing in the describe attribute output result. So then you need to be cautious and make sure that you return the output only the number of numerical values. So this is one trick question which would come for you. Apart from it, the following stuff is present. So dot info, an attribute which is utilized for printing the various kind of data types and simple information. Then this is a function in which you can sort values. Okay. For before sort values, the attribute which you are seeing dot is any is basically utilized for observing or having the count of the missing values in our data. Then there's this thing called shape, which basically tells you the available number of rows and available number of columns in your data set. So it is a tuple and you can extract these values. Now, as you can see, there are some tasks which are present in front of us. So you'll be trying and seeing these tasks. So the first task is about basic indexing, selection of all the sales data from North region and all of these topics. So you can use these resources and get these resources from the link or the place or location which I mentioned where you can find them. Let's quickly see what are this task of basic indexing, grouping, filtering, applying. Okay. So this is the first thing which you can see, an attribute of region or an attribute of unique for this specific column of region. So let me tell you about this also. What you are seeing here is a method of writing or identifying or extracting a simple row or a column from your data set so that you can do based on the indexes which you have with you. That's how the stuff is done. There's an attribute called unique, which is used for finding unique values. In a similar manner, there's another way of writing it. So it could either be written in this parenthesis form or followed by a dot. What is the catch with the dot? Okay, that could also be one trick question. So whenever your column name is suppose a string with two separate words, let's say I say date today. So you have a column say date today, and you can see that there was a white space in between them. So in that case, you would never utilize this specific notation. So make sure whenever you are utilizing the given notations, you ensure that the proper formatting is being utilized. Value count, it is another attribute you can see in which you will be returned with the unique values along with their present counts. What you see on the screen now is called conditional statements. So what are conditional statements? So it is simply like the SQL queries which you know about. So SQL queries utilize stuff like you're giving some sort of condition, you have some sort of available space. That is what it is. This data frame is your playground, and then you're giving some conditions or requirements which you need to fulfill and provide your answers. So this is what conditional statements help you with. You'll be having this data frame as your playground, and then on this entire data frame, you need to apply some specific conditions which you need to follow. And based on those conditions, you will extract some answers. So what you can see here is a conditional statement which is utilized for finding the portion or the data points in which the region was say north. So this is how you write the conditional statements. Parenthesis followed by the data frame name, then whatever attribute you want to work on, and then its value. So it is a very basic statement, and eventually as you would start working on this stuff, the stuff would get a little complex or the conditional statements would start getting better. So now, as you can see here, this one, the specific statement is about sales data, and from the sales data, you are using the product, and then there is separate condition given to you in which the given products of laptop and phone, the units sold are more than 10. So here you are utilizing the operators of and or maybe some sort of negation as well. So in the conditional statements, the bigger parenthesis, which is in yellow color, is your initial parenthesis. So within the initial parenthesis, you will have some sort of available stuff that could be conditions, that could be values, and all of those. So what you need to do now, you need to add or provide conditions within it. This is how you write conditions which are connected with the help of some sort of statement. So the original question would have been something like you need to extract those data points in which the product is either laptop or a phone, and its sales or its units which were sold was greater than 10. So this is your how you are writing that statement. In the first parenthesis, you have specified the product, which is laptop or phone, followed by the statement that of and then given that the unit sold should be greater than 10. So this is you are writing a statement in which you have two conditions to be followed. The next thing. So next thing would probably be about grouping of data set, I believe. Yes. So this is about the grouping of data set in which you have the thing of aggregation stuff. So firstly, you are seeing in front of you is the use of attributes of dot lock and dot ilock. What I would emphasize on is their meaning. So dot lock is a basically abbreviation of the thing called location. So here, when you are expressing something with this thing called dot lock, you have to specifically specify the location. And whenever an I is added before lock, you call it as indexed location. So in that, you specify the index values. Now, within this parenthesis in which you are defining the location indexes or location values, there are two things which are to be taken into consideration. The first value would always be the rows, any condition which you want on the rows, and then followed by a comma. What you will have ahead will be some possible conditions on the columns or the values or names of columns. So yes, you need to keep it in mind that in the lock or ilock statement, you will be having two components. The first one of which is about rows, and then the followed one would be about columns. So in this specific, you can see that I've extracted entire rows or entire set of rows in which I had utilized only the columns of product, region, and total sales. And for that very reason, in the part of extracting the rows, I've given just a column, which means that I need all the values from there. Now, what you're seeing here is the ilog. Ilog, as I stated earlier, it is indexed location. So rather than giving the values or the names, what you're ensuring here is you are giving the indexes of the columns which you need. That is the major change you can observe here. Next thing, what we can see. Yeah. So what you are seeing ahead is just a method of writing or converting your values, say, into something called a list. So this is how you are doing it. And then the index which you will provide will return you the values as per that. Apart from it, what do we have? Okay. This is another method of writing the log statements or data strings, that rather than using the dot log statement, if you don't want to specify some condition on the rows, you could just use this double parenthesis or double square brackets and then enter the values of the columns which you need to utilize. Okay, this is something where the group by clause would come. So group by is basically a method of writing conditional statements with the help of lesser space complexity, I can say. So you would be expressing the information with the help of a simplified or specific function called group by, in which you will be providing the necessary values and the conditions. So what you can see here is in this next one. So in the parenthesis, you can see a attribute called product. So here the one in the circular parenthesis would actually act as your index now. And then this is what the value I need to emphasize on. So what the question could have been like, I need to group my data set in such a manner that I have to tell the total sales related to the different products that I have. So that is how the statement is written. Group by is the function you would be utilizing. In the parenthesis, you are seeing this value of product, and this ensures that it will act as an index value for you. And then total sales would be actually the values which you need. And then a summation is created to ensure that the sums are taken for this. Using the group by statement, you could actually write many of the conditional statements. As you can see in the next follow-up question, it is you need to find the top three customers by total spending. Now, what is different here? What is the difference is that you are specifying this specific into a separate data frame. So the output of the group by attribute, which it is utilizing the customer ID as your index and then followed by the total sales and its sum values. So rather than extracting this result as in place or on place value, you are taking it into a separate data frame. And then you could in future or in the entire global space, utilize this data frame anywhere wherever you want. Sort values is another function. You can basically be asked question on this. So there are two things, dot sort values underscore values, and then other is dot sort index. So as the name suggests, sort values will ensure that the values are sorted, whereas sort index will ensure that your index is sorted in a specific manner. By default, this attribute of ascending is true. Ascending order would be followed. If you want things to follow the descending order, you will have to specifically mention ascending equals to false. There is this another attribute called n largest, which could be utilized as well. It is an inbuilt feature. This is about calculating. Okay, this might be an exercise for all of you. Now find all sales that occurred on a weekend. Okay, this is where the date time thing is come. So date time is like you can say a kind of brief introduction or the starting point of time series analysis which we study. Time series analysis is a bigger thing and it's a vast domain in itself. But date time is a specific kind of data type you can consider as well. So in this, you have to use this specific thing called .dt, which stands for an abbreviation of date time. And then it has its own attributes, say date of week, day, month, year. And then using these values, you can extract things whichever you need. So if I have to briefly tell you something of this, let's say you have some specific column in which you have some date values. So this entire column could contain some date values. To make your task easier, what you will do is firstly convert it into a datetime object. And then this datetime object can take various values like day of week, day itself, month itself, and year itself. So only with this one specific date which is provided to you, you can extract four valuable informations. What date of the week it was, day of the week it was, what was the date exactly. So you can simply extract the date from this specific thing called date. What was the month? What was the year? So with just one simple conversion, you can extract valuable information of stuff. This is how datetime helps you. Let's proceed ahead then. Okay, another thing is creating a new column. So for creating a new column, what you'll have to do is basically mention your data frame name along with the name of the new column which you want within ports, and then some of the conditional statement or thing whichever you want to follow to ensure your data new column is created with a specific set of rules. So what you can see here is some condition which was given to you, and based on this conditions or these provided stuff, things would follow. So budget was given, a mid range was given, a premium value was given, and based on this provided information, what you will do, you will create a new column. So how will it proceed? This is how it will proceed. Okay, so sir has used a function so that we could show you the utilization or help of the apply function as well. So what I've done here is specified a function called define price category, and then a function definition is given within it. So the price is being followed in for some given values, a condition has been specified. Now What I want to do is add a new column called price category in my dataset. There it is, the column created. Now, within this new column which is created, what I want, this function to be applied. This is the apply function. What it does, okay, so the apply function, what it does is basically it utilizes your provided conditions or statement of the function which you have utilized, and then iteratively work on every row in your data set. And then after whichever the condition which was present in your statement or in your function or whatever computation was part of your function, that thing would be followed and you will be having some sort of answer. That answer is specifically stored in this new column of price category. If this apply function has came here, let me also share something information about it. So regarding this apply function, by default, okay, should not write with this, write with something else. Let me utilize this one. Okay, so by default, this apply function works on rows of data frame. So iteratively, it would work on every row of the data frame. Why is it so? What is it, the reason that it is working on the rows itself? So for these specific functions like apply, drop, fill, is any, something like that, um, you have an attribute called access, which is basically used to specify on what sort of access you want to work. Access has two values, x is equals to 0 and 1. This means rows, this means columns. Why I specifically emphasized on this point? There were some questions in the previous year question paper in which you can actually see the questions based on this value of x equals to 0 and 1. The question would simply look like to a simple function is written. I'm just applying the function on the data frame. I'll have a clear answer. And that specific answer would actually be present in front of you. But what could be a major missing thing? Your function might have been defined on some values within the columns, and there wasn't mentioned access or specifically 1. An error would be coming, and your entire answer would be wrong. So by default, every attribute has some default values with it. So for access, the default value is 0. If this default value has to be changed, you would have to explicitly mention it. Let's see if we have something else in with. Oh, yeah, let me also remove this. Okay, this is something about the data analysis. It would also be including stuff like that only. Let me see if there's something important we can talk here. Okay, nothing separate I should see here. Yeah, okay. So these were like the most basic things which you could understand or keep into consideration when you are working with a data frame. You should know about the conditional statements, how the conditional statements are right. You should know how you do the indexing. You should know about log. You should know about ilog. These are some things or some topics you should have a quick refresher about if your concepts are a little weaker in this portion. Apart from it, you should ensure that you are aware about utilization of functions, group by clause, and stuff like that. Basic operation of datetime library, you should be aware about it. That what does this day of week, day, month, etc. will help you with. Apart from it, sort values and basic attributes of like is NA, fill NA, drop NA, etc. That could help you. So this was the discussion about the data manipulation part. So I would like to take a pause here, and if we have some sort of queries, please ask. Okay, do we have any queries related to that portion? If not, give me a quick thumbs up and let's move ahead then. Okay, wonderful. If that portion was, is this collab code only taught in lecture two? No, this collab which you are seeing is available as the T resources. You could easily find them on the discourse forum. Okay, so I'll also share the link for your reference. Okay, let me help with that also. Okay, this is the specific post. Scroll to the top of this post. You will see a long post. It will be having resources of every week you have. Okay. Okay, but the question is same, right? All will be covered. In which you are asking in the TA collapse or the collapse which were part of the course? If you are asking about the course collapse, yes, everything is same. Yes, yes, everything is same. We have ensured that we follow the entire consistency. Okay, any other question we have or else I should move. Okay, I should move it then. Okay, so if this thing has been completed, let's move to the next topic, which is about the transformer stuff. So what are transformers? So you can say that transformers are sort of tools or sort of special entities within this specific world of data science or machine learning that will help you to make your tasks easier. So they are helpful for data preprocessing and clean ensure data consistency. So what all stuff does this include? So let's move to this part of data pre-processing and cleaning into consideration. Let's keep these into consideration and see the necessary things or steps which we have. So as all of us know that every machine learning model which we are creating or which we intend to create is basically working on some sort of mathematical intuition behind it, right? So to ensure that my model receives clean, neat, and structured mathematical data, which has no inconsistencies, I work on these or I work on the provided dataset with the help of techniques of data preprocessing and cleaning. It includes stuff like imputation, scaling, or even before scaling, we should specifically talk about encoding also. So quickly for quick summary about each of them, imputation, it is a methodology of filling the missing values or unknown or those values which should not be present in your data set. Okay, so this is what imputation helps you with. What is encoding? As the name suggests, encoding is a technique which is utilized specifically for converting your categorical data into some sort of numerical value because your model won't be able to work on some sort of categorical information. So that is what encoding is about. And then what is scaling? Scaling is done or performed to ensure that your data is normalized or standardized. Your data should be in a specific range or your values should be in a specific range for two reasons. So that your model doesn't give or start giving high emphasis on something in lower emphasis to other, as well as to keep your computation cost lower up. Okay. When it comes to imputation, it might include simple imputer or the KNN imputer. So these are two kind of imputation techniques which are specifically focused in our course. Simple imputer would include the stuff of mean, median, fill value, and most frequent. So I would give a brief about them. For the missing values, a mean value would be used if the strategy is mean. That is, the average of the given values would be utilized and filled in the value. Median, the central tendency or the central value would be taken into consideration. Fill value is a specific attribute which could be utilized to fill a value from my side. Most frequent, a specific methodology in which I can utilize the highestly occurring or the most occurring value. Other than that, what is KNN imputer? It works on the specific technique of K nearest neighbors. So K is a hyperparameter. You will provide some parameter name. It will work on that. Choose the distance metric, maybe Manhattan or Euclidean. You should know about what Manhattan and Euclidean are. And then based on the given metric, it will provide some sort of result to you. encoding. There are specific sort of encodings as well. So we know about one hot encoding, we know about ordinal encoding, and we also know about label encoding. These are some important topics you should be aware about. So what does these do? Let me give a quick brief about them. Okay, let's take some different sort of data. A, B, C, A, B. Okay. Let's say this is a random data in which you have three unique values, say A, B, C, and then they are occurring in some sort of repetition. So if I have to explain you, say, one hot encoding with this. So let me extract the data properly. Say this is your data set, and then what is one hot? So quickly, what is one-hot encoding? You need to take into consideration the unique values which you have. What are the unique values which I have in this data set? A, B, and C. Alphabetical order would be followed. I'll be creating separate columns for each of them, and then the binary method or filling method of Boolean would be utilized. So for whatever row, whichever value is present, you will give it a 1, and then followed for the other, you will be giving a 0. In the first one, say this A is present, so it will look something like this. Then for the remaining, it will follow something like 0, 1, 0 because B was present in second. For the C one, it is 0, 0, 1. And then the initial two would actually repeat themselves. Okay, this is something called one-hot encoding. It has a specific attribute called drop first. What is that specific attribute drop first? That will ensure that one of the provided or the first row is actually excluded from your dataset. What happens in that case? Let's say if I drop this entire column, okay? So I would encounter a case like this in which both B and C is actually 0, which is itself an implication of saying that none of these values would present. It was the last value or the other values which was removed for our case. So why it is done? Just to reduce the size of my matrix, because it is not a case that you will be seeing a data set in which you'll be having so less number of values. You will be seeing a data set with vast values as well. So that is the case in which it helps. Other than that, what is ordinal encoding? As the name itself says, it's for the ordinal data, not for the nominal, but for the ordinal data. What is ordinal data? A data which follows some sort of a order, say good, bad, and worst. These are three type of categories, and they can follow a specific order. You can say. So based on this specific ordinal encoding pattern, you can fill some sort of order or fill this specific column. Let's say, let me give you an order here. A was greater than B and then was greater than C. Okay. So in such a case, if there was a situation like this, ordinal encoding could help you, because what will it mean? It is a kind of indication to my model that I want that A should be given a higher priority, B should be given a more higher priority, or C should be the highest. Okay, something like that. So what I told you is kind of the inverse, or writing it in a different manner. Apart from it, how should I perform this? Why I specifically followed this order is because the functionality of the ordinal encoding. Why so? Because ordinal encoding follows a specific order or methodology of filling the values with alphabetical order. As I told earlier, that encoding is working only for the cases or for specific data types in which your data type is object. So you won't encounter a case in which you have numerical values. So what will happen? The element which comes the earliest in the alphabetical order would be given numbering based on that. So A would be referred as 0 here, B would be referred as 1, and C would be referred as 2. So I have three unique values, and then because of there was some sort of order present in them, my model would consider these three different values as three different entities. And based on these three different entities, some sort of learning would be created, and my model would be actually able to understand that. So how will this thing come to be like? So this one was A, so it will be called 0. maybe it's 1, 2, 0, 1. This is how the order would follow. This is what ordinal encoding is. You could define the order as per your choice. There is a parameter within the ordinal encoding in which you provide the categories list, and that specific categories list would actually consider or take into consideration the specific order you have. Next thing which we have is this label encoding. So in simple words, label encoding is also very much like the ordinal encoding, except the fact that label encoding could not be part of something called a transformer. So the transformer thing about pipelines or column transformers, which we are going to discuss a little ahead, just keep into mind, label encoding cannot be a part of that. Okay. It is a condition associated with label encoding that it would work explicitly on a single column or a single entity at one time. It could not combine multiple values within it. Let's see about scaling then. Was it written properly? So what is scaling? As I told you that to ensure my model is seeing a normalized or a standardized data set, and to keep into consideration the situation where there is a proper reduced computation cost, scaling is something which we follow. Three types of scaling is what we have: standard scaler, min max scaler, and max absolute scaler. These are the three types of scaling you follow. Each of them has a formula. So this is called standard scaler, in which you use the standardization technique. This is the mean value, standard deviation. For the min max scaler, the formula is x minus x min on x max minus x min. And lastly is max absolute scalar, in which what you do is data point and divided by the maximum absolute value. So even if the data point is a negative one and have the highest amount, you take its max and then consider it for every possible data point you have. Okay. You must keep these formulas into consideration because there will be questions in which you'll be giving small data sets or data frames, and you'll have to imply these formulas on those to find some sort of values. Okay. So they should be present in your mind. Now, these stuff of encoding, imputation, scaling, they could be utilized into data pre-processing. So, if you have to perform these tasks of, say, imputation, scaling, encoding separately on every column which you have in your data set, it will be very tedious for you. So, to ensure that this task is not extremely tedious for you, we have got the help of things called transformers, specifically, say, in our course of this column transformer and pipeline. What are these? They are specific helping tools that help to utilize or input these tasks of encoding, imputation, and scaling on a bigger chunk of data in one go. Simpler statements, if I have to tell you what these does: column transformer, parallel, parallelly, I should not say like that. Parallel operation on different columns with similar functionality at a time. Pipeline. What a pipeline is: sequential operation on some columns where the columns would actually be consistent but different operations. So this is something which is actually very important part of your course, and you should be aware about this. So if you are lacking your preparation surrounding to this portion, please practice it. Understand the syntax of these things, how do they function, and all of those. So let me quickly show you the basic structure of how these thing works. So let's say this is a big box in front of you, and okay, what we can do is okay, let's follow with this only. So let's say this is a big box in front of you, and then part of it are different smaller components which are combinedly working on some sort of thing within your data to give a common output. This is how a column transformer actually looks like. The task is being performed. Let's say it could either be imputation, it could be encoding, or it could be scaling. So a similar type of task is actually being performed on each of these entities. But what you see, the small boxes are basically separate columns of your data. Whereas when it comes to a pipeline, your pipeline will have some steps which will follow an order and eventually result to an output. Okay. So what will happen on each of these specific steps? Some sort of thing would be happening. Let's say here it is happening imputation followed by encoding, might have something called scaling. Let's say feature selection. This is how things work in a pipeline. So step by steps, things will happen and you will get an output. Since this is a vast topic, you'll have to eventually give your effort into understanding something if you don't understand it properly. Enough resources are available on the portal. We have shared stuff. We performed all these operations. So if anything about the syntax or something is not clear to you, please refer to that portion and get your concepts clear in this part. Apart from it, what do we have next? Okay. Feature union is one thing. Yes. Let me also tell you about feature union. So feature union is something, let's say you want to perform, say, set of instructions, set one of instructions on some columns. So call one, okay. So this is set of instructions which is being performed on this set of columns of one. And then there is another set of instructions which is followed on this new set of columns called call to, okay. So what will happen? You tend to create different pipelines and column transformers for both of these. And lastly, what you want to do is merge this data set into one. That is where feature union comes into play. So you have this information or output results from both of them. You start combining them with this thing called feature union. And what will it eventually result you or help you with? What you will get into the output result would actually be a combined, or I should say concatenated data frame. Okay. So this is what something called a feature union is of help. So please make sure to quickly go through or about all these transformers, pipelines, and stuff like that. Okay. Apart from this, okay, so this was the initial content about data processing and stuff like that, which is part of our course initial 3 weeks. So a specific quarter of our course is basically about this portion only. Any doubts still here? Okay, good to see we don't have any sort of doubts, which is very nice. So yeah, give me a quick thumbs up if we should move ahead. Everything's going good. Okay, wonderful then. So then next of it, the week 4, it is a quick refresher about all the algorithms which we're gonna study in our course. Okay, so it is you can say a follow up of the things you studied in the MLT course. So what things could be asked from this portion? You should be aware about the equations. What sort of equation I mean? You should know about what are the equations associated with something like a linear regression, a logistic regression. How is a classification thing working? What are the basic calculation of probabilities happening in the background and all of those? Okay, this is what you should be aware about. You should be aware about the loss functions, or I should say the optimization functions as well. So these things you should know. What are the different set of models that could be used, or what are the different set of techniques which are utilized in models? So we have the linear models. We have something called probabilistic models. We have tree models. We have the ensemble techniques. And apart from it, yep, the support vectors, multi-layer, yes, multi-layer models. And I should say neural networks, basically the simplest neural networks. So these are the different kind of models which you have in your course. To quickly quote what stuff is present in all of this, linear regression, logistic regression. I mean, I should not specifically say the regression. Both regression and classification would be part of it. Okay. So linear, logistic, stochastic gradient descent, and naive based stuff, and support vector stuff, decision models, ensemble models would include stuff like bagging, boosting, voting, stacking, and we have the random forest as well present with us. And for the multi-layer models, it would be the specific or the simplest multi-layer perceptron models. So you should have a brief about idea about each of them, because you might see some basic questions arising with them. You should know about what penalties means, what is the meaning of terms like alpha, what is tolerance, what is regularization. These are the parameters which are associated. So you should be aware about these concepts as well. Any questions in this portion? Since this is a very vast portion, I cannot take everything from the scratch and cover it. So I've given you a brief idea. Every resource is available. You can refer to it wherever you're getting stuck. Okay. If you want me to cover something, you can let me know. If you have some sort of query. Okay, looks everything is good. So let's move to the bigger portion then. The next bigger portion is week 5 to 7. So what week 5 to 7 content is? Week 5 is every sort of I should say the regression problems that can exist. So week 5 is regression. Week 6 is classification, evaluation metrics. So for every sort of algorithm which I gave you an idea about, you should be knowing its regression version and its classification version. What is important in the contents of these weeks? You should know the stuff in the documentation of it. So what are the various parameters associated with each of these models? What all these stuff we have? There are some sort of specifications related to different models which we have with us. So you should know about this loss values and things like that. And then evaluation metrics, I'll tell you them in detail. So let's move to the some sort of documentation stuff to see what these things works like. Let me show you the documentation of SGD, building block of entire portion. So let's begin with this GD classifier or regressor. Okay, let's start with SGD regressor itself. Let me share that portion of the screen then. Okay, what you can see is basically what a documentation looks like. Now, within a documentation, as mentioned many times earlier as well, there are two portions. One is called the parameters, and the other ones are the attributes. Both are equally important. For every model you have, there are set of parameters and there are set of attributes. Parameters, you can say they are like the conditions, and attributes, they would actually help you to provide with the results or the learnings which your model has taken. For every model that you will study, there are three basic steps that follow. There is a method in which you start with initiating your model or initializing your model, followed by a step in which your model is fitted on the data set, and then a part where you try to extract some sort of prediction or some sort of evaluation result or a metric with the help of your model which you have trained. As I mentioned, a portion of fitting, there is thing called train test split as well. So what is that? For your data set, you have different sort of things present with you. There is one training data set in which you have some sort of labels present with you. What I mean by labels, they are the answers. Okay. So you make your data set learn with that. You give the feature matrix, you give the results, and then with the help of these feature matrix and result, your model learns something. Okay. Apart from this, the next follow-up thing is called a validation. So validation is actually a part of training, which you can basically consider as a revision. So you take out or segregate out some random sample of data points with you. And then with the help of those randomly sampled data points, you create a sort of an unseen data set or a revision set for your model on which you judge your model's performance. And then there exists the test set. What is the test set? The test set is basically, or in simplest terms, I could say, the actual test your model has to give. Okay. So these are the parameters you can see. Now, what questions could be asked from this portion? You could be asked question based on specific small information that is associated with major parameters. Okay, like here you can see, as I have told earlier in my sessions, there's this thing called loss. Or apart from loss, I should say that this thing called the SGD model, the stochastic gradient descent. It is basically the building block. Every model you are probably seeing currently is some or the other way a variant of the STD model itself. So for various values of losses, various values of penalty, and you can see stuff like alpha and learning rate with different values of these, you can actually extract different sort of models without. So in comparison to, let's start with loss. Okay. So since this is a regressor, the parameters are actually very much specific. In case of regression, a set of parameters which is provided to us is very specific set of values, and they tend to follow a general trend. But when you actually move into the world of classification algorithms, things start to change. So this is what it looks in the world of classification. And let me show you the various cases you have. So you can see there are a number of values for the losses you can see here, and each of them has a different interpretation. There's this thing called hinge, which works, or whenever the loss is hinge, it means your model is basically working like a single or a linear cis-cohort vector machine model. When it is a logged loss, your model is converted into a probabilistic classifier. It will work like a logistic regression. Similar manner, when you tell it as the loss value of perceptron, it will ensure that it starts working as a perceptron model. What is a perceptron model? It is a linearly separable dataset model and things like that. Next thing, what you can see here is called the penalty. What is penalty? Penalty is kind of regularization which you want to ensure. What does regularization helps you with? It helps you to ensure that there is no sort of overfitting on your data set. To help or to get rid of this overfitting stuff, penalty is something which we utilize. There is a very common question which is asked in penalty is about this thing called elastic net. What is elastic net? It is a combination of both kind of penalties, L1 and L2 regularization. What is L1? It is lasso regularization. What is L2? It is ridge regularization. So you must be aware about it. You must know the values of each of them. Then what is this alpha? Alpha is basically the regularization term or the intensity or the multiplication constant you want for every specific data point or every specific penalty that would be instantiated or created in your model. There's this thing called L1 ratio. What does this stand for? This thing of L1 ratio is basically the amount of L1 regularization or L1 penalty you want in your case. So question is also asked with this that you're given, say, a model with elastic net penalty, and say 0.2 is the amount of lasso penalty which is implemented. So what you need to tell what would be the amount of the ridge penalty. So what you would need to do is just 1 minus the given L1 ratio, because L1 ratio plus L2 ratio would always result in 1. So this is some sort of condition you must know about. You must be aware about what these things like fit intercept mean. Fit intercept means you want sort of intercept in your best fitted line or best fitted model. Your model should not pass, or your boundary or decision boundary must not pass from the origin. What is the meaning of max iter? The maximum number of iterations your model should work upon. What is this meaning of tolerance? This question about tolerances came like n number of times, in which you need to tell what is the idea behind the tolerance, how it helps us. Then there is this thing, what is njobs, which is used to take into consideration that every processor is used. What is random state? To ensure that shuffling every time or at every point in your model, a consistent shuffling is followed. Learning rate. It is in the simplest way I can say that learning rate is kind of a starting point or a beginning point in which you're telling what methodology should your model follow, what pattern it should take the values. But from it, okay, this is ETA0, which is a value of the learning rate whenever you set it to constant. Poverty. This is called the in inverse or the scaling learning rate. Okay, exponent for the inverse scaling rate. What does early stopping mean? What does warm start mean? These are small things which you should know about. So this is something that you will observe in many sort of linear models you will be, I should say, targeting or interacting with. For linear models, this is a set of parameters which works. I mentioned a thing called warm start. It means that for every different iteration, should the learnings from the previous iteration should be considered or not. This is you need to keep in consideration or understanding. As soon as you are done with the linear models, there is thing of tree models as well. So let me show that also. Skill and dot tree. We have it here. Yes. Decision tree classifier. We should utilize decision tree to understand this. So what are tree models? These are the simplest models in which, based on some sort of condition, you start creating splits in your data set and get different sort of results with them. What is one good thing about, or I should say, a catch about tree models? We studied earlier that scaling was an important component of data preprocessing, right? So in the case of data preprocessing, scaling was necessary, but when it comes to the decision tree models, scaling is something which you can actually omit. If your data set is not even scaled, yep, decision models are or tree models are something that you can work upon. So you should know about these parameters which are present. What is this criterion? What are these impurities and stuff like that? What do I mean by max depth? That how much depth my tree is going? What is the meaning of mill sample rate or maximum features, or I should say max leaf nodes? Everything you should understand because there could be sort of theoretical questions which could be asked from this. Anything we have apart from it? In this, yep, there is this thing called dot tree. You should know what this dot tree underscore does. It actually extracts the tree model for you. So yes, we can have questions from that portion as well, in which you will be given the dot tree method, which means that you have actually extracted the tree. And then based on that tree, there could be attributes which could be utilized to give values like you should answer, or you should be able to answer the value of depth. You should be able to answer the value of leaves created, the nodes created, the input data points which was taken into consideration, and stuff like that. Then moving ahead from the tree models, the naive Bayes model. You should know what the basic intuition about naive Bayes is. As the name itself says, naive Bayes. It follows the naive assumption that the columns which you are having in your data set are independent of each other. There are different sort of categories or types of the naive Bayes model, which may follow from the Gaussian to multinomial. So this is kind of assumption which I'm assuming. Gaussian means my data would be Gaussianly or normally distributed, whereas multinomial means it would be taken for the multinomial data sets. You should be aware about this. Support vectors, how do they work? Perceptron, how do they work? They create a simple decision boundary, they include a penalty, what those penalty means, how do I give the bribes and stuff like that. So there are these basic terminologies you should be aware about because you might encounter questions related to this stuff. And what apart from this we have? Yeah, ensemble methods. Ensemble methods are important. What are ensemble methods? They are complex models or bigger models created with the help of smaller models. Techniques like bagging and boosting. What do they mean? Bagging, creating small sample bags of different data points, and then training one common model on those different sort of data points. How do I get the result? We use thing called voting. What is voting? There are two types of voting. So voting is simply what you understand by the word vote. There's some sort of judgment, and based on this judgment, your model is created. Try to get some answer. So you must be aware about what soft voting and hard voting is. What is soft voting? Rather than extracting the exact prediction from your trained model, what you will start to do is extract information, something like probability. You will be having probability for each class you want. Then you will sum those probabilities, you will take an average, and then the highest probability, that would be your answer. So this is soft voting. What is hard voting? It is exactly like called the majority voting structure. You get the predictions, the higher predictions, or the count of the prediction, or the count of whichever class is the highest, you take into consideration, and that is your answer. So this is how I should say the ensemble techniques work. What is boosting? Weak learners are implemented sequentially. We have sequential weak learners. Data set is passed to each of them. Some learning is taken, and eventually final output is created. This is majority stuff about the models which you have in your course. Multi-layer perceptron. What was that? Multi-layer perceptron was something called the basis of neural networks. So let me tell you the neural networks with the help of this diagram. Maybe that would help. Okay. Yep. Just hold on a second. In the meanwhile, if you have any questions in this entire portion, you can ask.
So what's the difference between soft and hard voting?
Okay, okay. Let me show the screen where I was writing. I can actually tell better there. Where's that window? Here it is. Yes. So you asked about soft voting and hard voting. Okay, let me help you out with that. So there are two things called prediction, and one I can say the predicted probability. So most of the models which you encounter in your course would actually be capable to answer both of these values. Either they can shoot actual predictions. Say I was giving you an example of a classification algorithm. So either it could answer me exact value of either my answer should be a 1 or a 0, or it could answer probabilities to me that for the class of 1 I have some probability say 0.4, for the class of 2 I have say a probability of 0.6. This is how you can take the predictions. Now here is what the things of soft and hard voting comes. Suppose consider a case of bagging itself. Okay, as mentioned, it will have small bags of chunks of data which is to be taken into consideration and one governing model. So what will this governing model do? Every governing model will shoot some sort of data to each of, or will take every chunk of data within it and then output something to you. Let's say these are the outputs which I receive. What would be it? Okay, I say 0, 1, 1. So let me tell hard voting. What is so hard voting in the simplest term is majority voting. Okay, this is this thing called majority voting. So what
So
should we do?
0, 1 are like labels or
Yes, yes, these are just the labels. The
Okay.
output labels, the classes 0 and 1, nothing apart from that.
There can be
So,
multiple labels apart from 0 and 1 also.
yeah, you can have a multi-class data.
Okay, sir.
So what is majority voting? The count would be taken into consideration. The count of 1 is 2, whereas the count of 0 is 1. So what should be the answer based on this? 1 should come as an answer. Why? Because it is available in the majority.
Yes.
Okay, majority of 1. But what is soft voting? It is something which is not very much taught. Soft voting. So rather than having abstract answers or abstract values of these specific classes, what you'll have results something like these probabilities which I have here. So let's say for each of these which are created here, let me give them some names. Let's say this is A, B, and C. So let me write some probabilities. For A, let's say for 1, the probability was 0.3, and for 0, it would be 0.7. Then for B, I can say it was something 0.25 for class 1 and 0.75 for class 2. Lastly, for C, I can say something, say this is 1, this is 0, this is 1, where I say it is 0.8. Then, okay. So how will soft voting return an answer to you? You will find the average of values for both the classes. So for 1, what will be the average of values? 0.3 plus 0.8 plus 0.25. Sum this divided by 3. So this is for class 1.
Got it,
Okay.
sir. Got it, sir.
Similar manner, you can do it for class 0 as well. 0.7, 0.75, 0.2. Take the outputs, whichever is the higher value, that would be your answer. This is what soft voting works like. Okay.
Yes, sir. Thank you, sir.
So yes, as I said, you should be aware about these things. You have to go through the parameters once. Maybe you could refer to those lectures in which we have thoroughly discussed about each of the parameters. So wherever you have some sort of idea about or some sort of missing void in your knowledge, you could quickly go to that portion. Maybe read a quick about the parameters and have an idea about general values. Okay. Evaluation metrics is something. So whenever your model is created, you have to evaluate the performance. So what is evaluation of performance and how does it work? To evaluate the performance, we have two types of models. Firstly, we have regression and we have the classification. Sorry. So for the regression models, what sort of evaluation metrics we have? We have something called the R2 score. Classification, we have different set of values. I'll let you know about them. But what is firstly for the regression one? This is formulated something is 1 minus, okay, not SSD, I should say with the formula itself. So y minus y prediction square divided by y minus the average square. So if I have to tell you what these mean, firstly, this y which you are seeing here refers to the initial label or the main label. So the actual label value, okay, which has been part of your unseen data. Whereas this y hat refers to the prediction based or created by your model. This y hat is the average value. So let's actually take one example and maybe try to find some interpretation about them. So consider a regression problem in which I give you this set of y true. The true values are some saying, say, okay, not 0. I should not take it 0 as but 1, 2, 4, 6. Okay. And then let's say this is column of y prediction. So y true is something which your model should have predicted the values. Okay. these are the predictions which I'm getting. Let's say 1.5, 2.5. I'm getting this as 4, and I'm getting this as 5. Okay. Now, let's try to find the R2 score in this case. So we have found this thing called y true, which is this y here in both the cases. We found this thing called y pred. This is not peak, this is pred. Okay. We found this thing called y pred, which is this y hat. This one thing which is missing, which is this y hat. Let's find this y hat also. The average of true. So what is the average of true? 1 plus 2 plus 4 plus 6, 13 by 4. Okay. So why we are taking this thing called y hat? We assume that the most basic model which one could create would actually be something like a model which is actually returning the mean values to you only. Baseline model, and based on the comparison between the baseline model and how good my new model created is, we are utilizing this value of y dash. Okay. So let's evaluate these values. What I have to do is basically have the summed values for both the cases, and then perform this calculation. Okay, let me write it in a better manner. Spaced a little more. Something like summation here and summation here, and a missing line. Okay, right. So let's try to find this first parameter of y minus y pred square. Okay. Easy thing to do. 1 minus 1.5, 2 minus 2.5, and then eventually this. So it would be 0.5 square plus 0.5 square plus 0 square plus 1 square, right? I can evaluate and find this. So
0.25.
yes, 1.5 is what you will get. Okay.
Yes.
Maybe to make our calculation simpler, and okay, just to make a calculation simpler, I'm just assuming this is 4.1 as of now. Okay, in the simplest of values, not
Okay,
to
sir.
everyone. So what will be this value of y minus y bar whole square? How can I find this thing? Now here I have to take into consideration, say 1 minus 4.1 square, then 2 minus 4.1 square, 4 minus 4.1 square, 6 minus 4.1, and then this whole
So
square.
better we can take 4 square, right? 4 instead of 4.1.
Okay, if you want that, okay, let's take this
That will
as
be.
4 just for assumption. So this will be divided here as well. Okay, this revision would matter. That part also.
No, no, sir. That 1 minus 4.1 instead should be like 1 minus 4.
Yep, I understood that thing. I understood that. I was just corrected that. So just evaluating these values. So 9 plus 4 plus 0 plus 4 again. So we have got another sort of result from here. 17, let's say. So this is the worst result you should actually obtain with the baseline or the most basic model you can create. So how can I now find my R2 score? My R2 score would be 1 minus that value, which was 1.5 divided by 17. This is R2 score, right? And this is some value which will actually tell how good your model is. Now, based on this evaluation metric, what is something that I can say? The
It's
higher the value of R2 score, or the closer it is to 1, the better kind of model I have, right? Because I should have a model which the predictions are pretty good or pretty close to what I actually want. Another catch, R2 score could be negative. Though it looks like that it could have the least value of 0, it could lie in the range of 0 to 1. But no, that is not the case. R2 score could be lesser than 0 as well. It could be a negative value. What do I mean by negative value? It could be a theoretical question that your prediction model is even worse than your baseline model. That it is giving predictions that are way beyond the simplest model which we can create. So this is about R2 score. Apart from it, what are some other kind of errors which is associated with your regression model? You have things called like mean squared error. We have things called like mean absolute error. We have mean, or not mean, but I should say log squared error. Log squared error. Okay. So you should know what these things are about. Okay. So mean squared is, we say it would be a mean of the squared difference. So y minus y pred in this value which you are creating. What is mean absolute? Rather than doing the square, it would be the summation of absolute values. What would be log 1? It would be summation of this y minus y pred, and a log value of this would be taken. So these are some different kind of errors which could actually be calculated in such cases, right?
So last one is log square error,
Yes, yes. Oh,
but you are using
my bad.
absolute.
My bad, my bad. I did it wrong there. B square because to ensure consistency. Yes. I didn't notice that. Okay. So this is how some things can be there. There is one more kind of theoretical question which arises from this portion is about a thing called scoring. So there is this thing called errors. There is this thing called scoring. Um, you would want or idealize a case in which the error should be lesser, but the score should be higher, right? So this is where the terms come like, if you want to utilize any scoring metric as evaluation metric. So if you want to use any scoring metric as a evaluation metric, you take into consideration the negative value of it. So the negative of every scoring actually works like an error. So my aim is to get a higher value of either a score or a lesser value of an error. So that is why we consider these negative values. Okay. Any doubts till this portion?
Sir, I have one doubt. Hello, am I audible?
Yes, yes, yes. You are perfectly audible.
Yeah. Related to R2 score, this is dot score. We had one question where we have like intercept.
Yes.
So in that, sir has told that like x variable, so which have, if they are like linearly dependent, then S1 will always be equal to S2. And if they are linearly independent, then we have to like check and we can find that. So how it's like, it's getting equal. Like if they are linearly dependent, then how S1 equals to S2? Something like question.
No, I understood which question you are referring to. It is about that fit intercept one, right?
Yeah, fit intercept true and false. So
Yes, yes.
yeah,
Okay, okay. I'll take that question and I'll show you what you are getting stuck at. Okay, I'll take that
yeah.
question, please. Okay.
Okay, sir.
Let me just quickly go through the remaining topics which we have. So yes, these were the evaluation metrics associated with the regression portion. Now we have the evaluation metrics of classification as well. For this, you have things, four things. Can you let me know what these are? It was okay. Yes. So we have some sort of answers. They are in the chat. I thought you would be speaking. Yep. So we have four major in the case of classification called accuracy, precision, precision, recall, and F1 score. Okay. These are some sort of classification metrics or evaluation metrics you have. Um, they all arise from a thing called a confusion matrix. So let me quickly show you what a confusion matrix is like.
We also have support now.
Support is just count, nothing else.
Okay, sir.
Okay, so this is what structure of a confusion matrix look like. I'm showing it for a binary classification problem only. Here you have something called the true values, and here you have something called the predicted values. There are associated labels 0, 1, 0, 1. Okay, I'm referring 0 is negative, 1 is positive. Okay. Now, this is the thing called confusion matrix, in which what you are basically taking into consideration, you might be having some correct values of 0 and 1, and you might be having some prediction values which your models would have created. Let's say I take an array of 5, 6 values to show it as well. So I'm giving you true values. Okay. Then let's say these are predicted values as well. Okay. So this is kind of a case in which I've showed you some probability studies. Now, a quick way to fill in the confusion matrix. So you might have questions like this in which you will be giving just true and predicted array, and then you'll have to create a confusion matrix at your end. And based on that confusion matrix, what you'll have to do is maybe tell the value of accuracy, precision, recall, or score, F1 score. Okay. So you must know how to fill them easily. First thing we should remember, on the primary diagonal, you will always have the true values. Any value apart from the primary diagonal would always be a false value. So what I can do is fill in it as true, true, and remaining could be considered as false. Okay. Now, whatever prediction is made, the second value is fixed based on that only. So if the prediction made is say 1, I'm referring 1 as P. So I will call it as true positive. So wherever the prediction value is 1, I will call that case as positive. And then wherever the prediction value is 0, I'll call that case as negative. And just you can see in quick ease, I've actually filled in my confusion matrix. Now, finding the value of these true, positive, false, negatives, they are very easy. As you can see, um, suppose I'm expected to find what are false, negative. What I need to keep in consideration, the prediction should be 0, but the true should be 1. How many such cases we have? Prediction should be 0. So firstly, 3 cases can be easily separated out. These are 3 cases, and then prediction 0, true value is 1. So only one such case exists where true value is 1 and prediction is 0. So let's write them. True, but I should say false. False, negative. So 1 is the count of false, negative we have. Similar manner, what is false positive? False positive means the prediction should be 1, true should be 0. So prediction should be 1, 3 cases, true should be 0. Only one such case exists. Yet another answer. Then what is true positive, which means both the true and prediction should be equal, as well as positive means it should be 1. So I need to count those cases and we'll put true and predicted are 1 each. So 2 of them you can find, right? True positive, 2 we have, true negative. Let's understand this also. What does it mean? True means both true and predicted values are equal. Negative means it should be 0 value. Such cases in which they are true and predicted are 0, we refer to as true negatives. They are also true. So using these values, I can actually fill in my confusion matrix. So true negative were 2, true positive were true. These were 1 each, right? This is how my confusion matrix is filled. Now I just need to memorize the formulas for accuracy, recall, precision, and F1 score. What are the formulas? Accuracy. True positive plus true negative upon true positive plus true negative plus false positive plus false negative. So you can say that in the simplest terms, what it means, I need to take into consideration my actually or corrected predicted values, and in the denominator, it is all the values with me. Next formula we have for precision. There's this thing called precision, which will look something like true positive upon true positive plus false positive. There is this thing called recall. True positive upon true positive plus false negative. A quick to remember. Precision starts with P. All the values in precision will have a P in suffix. Okay. You would be able to memorize it. F1 score. What is F1 score? It is 2 into precision into recall divided by precision plus recall. These are the important evaluation metrics you must know about. They are necessary in helping or identifying. You must know the cases where accuracy is important. You must know why F1 score exists, what is its need. So there's associated with the data imbalance, right? If your data is imbalanced, alone accuracy could not be a good metric. You must be having this understanding of what F1 score is, why it is equally needed there. Okay. There's this another thing called a classification report, which whatever happens is basically it is a detailed report in which you can see the accuracy, precision, recall, F1 score, and these weighted or averaged and macro average values for every class that you have in your data set. Okay. So you must understand reading of a classification report. You must understand what every attribute which is present in there in a classification report, how to utilize that. Okay. You must be aware about this thing. So till this portion up to week 7 of our course is completed. Now, as mentioned earlier, week 8, week 10, week 12. These are the new contents. What is the most important thing you should keep into consideration? The most important thing that you should keep into consideration that covering and watching the lectures at least twice so that you know every sort of information which is part of your lecture content. That is mandatory because there might be questions. There will be questions from that portion only. This content is new. This is being introduced for the very first time into the course, and you should be thoroughly aware about it. For some sample questions, yes, you will have to join in tomorrow's TA session. You will be just working on some questions there only. I have not I specifically, but we collaboratively, both me and the other TA, we have collaboratively worked and created some set of questions for your ease. You'll be taking them tomorrow. Just refer to that session because you can gather um, how to solve the question, how the questions would actually look like. Everything can be completed in this small span of 2 hours. So what I focused was covering an overview or a quick go through the entire course content so that you should know what things you need to emphasize upon. So as mentioned, week 8 is about text and images. So this is week 8. Okay, text and images classification. Next thing is week 10, it is of recommendation systems. And week 12 is intro to time series. So these are three important portions which you'll have to work upon. You'll have to understand this entire portion. Maybe refer to the lectures, at least have the basic idea about the things which are here. So tell you about in the recommendation and in the time series portion in the week 10 and 12, there are enough number of conceptual theoretical concepts along with some formula based concepts as well. So having the idea about what this theory is all about and what are the formulas which you will have to use, you should have them in your mind so that you will be able to solve the numerical questions that will arise in that portion. Regarding the text and image classification, so separately if I have to tell you, when it comes to text, it includes two things, the count vectorizer and the TF-ID. So you should know what a count vectorizer is, what is a corpus, how it works, what is its basic intuition, and how does the output metrics looking like, what is the evaluation criteria here as well, how do I fit a model in these cases. When it comes to image classification, you should know about how do I load an image into the environment, what is the specific library I'm utilizing, and apart from it, which attribute is utilized to visualize these images which I've created, what are the shape of images, what these three values in the tuple of the shape of image signify, how can I print, what is the printing statement do, trimming statements I should understand. I should understand of a systematical manner of loading my images into a zip file, and I mean loading my images from a zip file into the local environment. I should know about the specific portion of augmentation, how these codes are working, what will be the resultant things and like that, what is augmentation itself, how do I visualize these things, and eventually the classification metrics and all of those. They are combined into this portion. So provide special emphasis on this portion so that you can have the necessary information with you and would be able to solve the question. Regarding the last week, which is remaining, the week 9, it is based on unsupervised algorithms. Unsupervised. So what are unsupervised algorithm? Till now, whatever portion you have discussed is always associated with a label vector which you have. There would be some sort of label vector which would be present. It would either be continuous values, which means it is a kind of regression problem, or discrete fixed values, which means it would be a case of classification problem. Now, based on a scenario in which you are not aiming to gather or obtain some sort of insight from this evaluation label, but rather than you are focused on entitled towards gathering information only from your input metric, that is where unsupervised algorithm comes to play. So unsupervised, as the name itself is shouting, it is not associated with the values or with the labels. It is just based on the input feature matrix. In our course, you have this thing of clustering, in which based on some sort of data properties, you start grouping points into small chunks. That is what unsupervised learning or clustering algorithms do. It is part of our course and it includes two types of clusterings. One is the k-means and other is the hierarchical clustering, specifically the hierarchical agglomerative clustering. So one is k-means, the other is hierarchical agglomerative clustering. Agglomerative clustering. Okay. So quick idea about what these things looks like. So let's say this is a space in front of you, and let me say that there are two axes, I should say, salary, and let's say this is spending. So with the help of these two values, I can kind of observe or infer four types of trends, simple four types of trend. So we could have someone with a higher salary value. We could have someone with lower salary value. Now, based on this, what I can see, this is some spending value. Okay. Apart from it, we could have someone who is having too much spendings, whereas we could have someone which have lesser number of spendings. So this is how this data set looks like. So what these small crosses are basically denoting pointers to you. So you are getting small groups based on some properties, right? These small groups which you can actually create with these properties, this is what you call clusters. So these are four specific trends that you can say. So this is someone who has a lower salary and a lower spending. This is one type of behavior. Someone with high salary but still lower spendings, another type of criteria or grouping. Someone with high salary and high spending. This is someone with a lower salary but high spending. So these are four general behaviors which you can have. And then based on these such attributes, grouping my data set into smaller portions. This is what supervised or unsupervised algorithms focus on. Here, clustering algorithm. So if it comes to k-means clustering, what you should emphasize on stuff like what is k here? The k is a hyperparameter. What does this hyperparameter mean? It means how many number of groupings or how many number of clusters you want. This is hyperparameter k. Apart from it, what are the evaluation techniques or way of it, or what is the ideal way of finding this k? So how do I identify or find this appropriate value of k? There is this thing called elbow method. You should know what elbow method is. So elbow method is simply another graph in which you will have different values of k present to you. And then for every value of k which is present there, there would be a value of sum of squared differences, SSD, sum of squared difference. Okay, let me show you the elbow method itself. Okay, so this is kind of a graph in which on one axis you have this sum of square difference. On other, you will have some values of k. So they'll start from say 2, 3, 4, and go on to up to some value of k. Okay, and then this is sum of square difference. What is this sum of square difference? By sum of square difference, I mean to say what is the actual difference if different set of clusters are made. So say this is a case of two clusters. So what does this sum of squared means? Distance mean? You'll have to evaluate the distance between these data points and take into consideration their sum of squares. And with the help of these various values of sum of square differences, you will sum them and kind of plot a graph with you. Okay, this is not appropriate. Okay, yeah. So this kind of a graph would actually come into picture. And when you look into this kind of a graph, while see a sharp bend as you see in the human elbow structure. Wherever these sharp bends occur, it is an indication that, yep, this is some value of k we can actually take into consideration. So this is how you find this value of k. You must know about the working criteria of k-means algorithm. So to quickly tell how the k-means algorithms works, in the simplest term I can tell you is we define or keep into consideration a value of k. K means how many clusters I am aiming to create. Then based on this value of k, I randomly pick some cluster centers in the entire data space. Let me explain it here only. So let's say I was planning to have 4 clusters here. Okay. So these are some random cluster centers which we will create. For each of this random cluster center which is being created, a process or a distance thing would actually start to happen. How will this start to happen? Every cluster center which you have assumed will identify its distance from every data point present in your entire matrix space, in your space. Whichever points are near to whichever cluster center, that specific point would be associated to that cluster center only. So since these 4 points were closer to this specific cluster center, they will become its part. Similarly, these 3 points are closer to this specific cluster center, they will become a family. And just like this, small groupings would be created. And then a mean would be calculated for every data point which is present inside one cluster center. Every data point, you will take all the axis or the dimension you have, you will calculate the mean, and that specific mean dimension or coordinate which is created would be the centroid value. And then after the new centroids are created, the standard procedure in which you are finding the distance that will be carried out yet again. Every data point would be calculated, the distance will be calculated, and iteratively, your data points would reach a state or a place in which the tolerance barrier or margin would not be crossed. That is, there won't be any significant change, which means your algorithm has converged. And lastly, what will happen? You will get such distinct results with you. Okay. This is what basis of the k-means looks like. In similar manner, we have this thing called agglomerative clustering as well. What is this agglomerative clustering? So these are two axes. Okay. Let's say these are some separate data points on this. So my aim is to classify or fix these values into separate data frames, or not separate data frames, separate clusters. Okay. So how do I work in that? How does agglomerative clustering works? It starts with a simple top up approach. Okay. What is the top up approach? It follows that every specific data point is itself a single cluster. And then this algorithm starts working in such a manner that the closest points start combining. Okay. Every closest set of points will actually start to combine. Let me show you it with the help of the shapes itself. That would be the easiest way to do it. So each of them was initially considered a cluster center in itself, or a cluster in itself, and then the nearest points would actually start combining. So assuming that these are the closest points, okay. So this is one created. Then yet another one would be created. So maybe these three are closer. This is one clusters, and now another one which is nearer would be taken into consideration. Okay. So the bigger one. And then lastly, all of these would be taken into consideration into one big set. Okay. This is how the agglomerative clustering is working. We begin from every small cluster for every data point, and lastly move to that point where every of them is combined into one cluster. After this entire thing is done, what you tend to do is create a structure called a dendrogram. So dendrogram is what? Dendrogram is basically the graphical representation of this clustering or the hierarchical agglomerative clustering portion, in which on one side you have the various points which you have. So let's say these are 5 points which I had here. 1, 2, 3, 4, 5. Okay. So I'll start clubbing those points which were actually closer to them. So initially 2 and 5 were very close points. So I will club them into one. This is one point. Then followed by it, one was added to this specific value. So this is another addition. Then 4 was added to this entire portion. Lastly, this third was also added, and we got a bigger cluster, right? So this is what a dendrogram looks like. On this axis, you have these SSD value itself. So for whatever threshold of SSD value you have, you will maybe create a partitioning line. Let's say this is my partitioning line. And then after this partitioning line is created, I'll have the number of clusters I want. So this one is one cluster I wanted, and then 3 and 4 were the separate ones. So 3 clusters would be ideal. This is how this portion of agglomerative clustering dendrogram works. So this is what you will have to study here. Last thing which remains in this portion, um, that is called silhouette score. So what is the silhouette score? It is another way of finding the appropriate number, okay, or appropriate values of cluster. So the formulation, if I have to tell you, it is something called a BI minus AI. Then in division, you have something called max of AI, comma BI. What are these AI and BI respectively? AI is within cluster sum of square distance, and this BI is intra cluster sum of square distance. Let me show this with the help of an example only. Okay, we can take an example like this. So this is one cluster, let's say, and this is another cluster, let's say. So how will this work? We will take into consideration the closest point of both the clusters. Okay, let's say these are the closest points of both the cluster. How do I calculate this value of AI firstly? So the small I which you are seeing refers to the cluster which we are talking about. Okay, this will be 2. So yes, This is cluster one. This is cluster two. So suppose I'm finding or aiming to find this value of AI for the cluster one. So AI for cluster one, how am I finding this? I will calculate the distance between these points. Okay, that is the nearest or marked point. A value would be found here. Let's say val one. In another way, what I will do, I'll find the value of BI for cluster one, in which what I will do, using this nearest point, I will evaluate the distance for the remaining points in the other cluster. These will also be square distances. Okay. We will find these small values and summation would be created and another value 2 would be created. So whichever of them, val1, let I saying, would be greater than val2. So my salute score will come out like val2 minus val1 because bi minus ai. And then since val1 was bigger, I will take value 1 and 2. Okay. This is how you utilize the salute score thing. This is eventually created and it ranges between -1 to 1. The more it is towards 1, the better the score is. The more it, the better the cluster arrangement is. The more it is towards -1, the worse the cluster arrangement is. Okay. What does silhouette score actually signify? It actually signifies that if the value of BI is higher, it means that the clusters are far away from each other, which is good for us. We want the clusters to be far away from each other. Whereas the value of the AI, when it is lesser, it means that the points are closely compact or the within cluster sum of square distance is very less value. So this is actually what I want. I want the distance between separate clusters to be very much, but I want the intra-cluster distance should be very less. This is how silhouette score works. So this is another important metric when it comes to silhouette score. So in the simplest of terms, what I can tell you that this was the most major content which was part of a course of machine learning practice. I've covered every possible concept that I could have covered in this 2 hour window. I've told you every possible thing, every possible tip which I had with me. Please practice on more stuff as much as you can, and then that will help to improve your preparation. Apart from it, whenever you have any sort of question, please feel free to ask on Discourse forum. Join in, ask us. No issues with that. Okay. So this is what I was willing to cover. Apart from it, when it comes to questions, yes, I'm specifically emphasizing tomorrow is a TA session. You will be just solving questions. And even in the previous sessions which have happened, we have taken question practice only. So for all of you who want to practice questions and watch the question, you could please refer to the TA session. Everything is available on the link which I shared. I'll also comment that link in the video also, which is on the YouTube portal, so that you could easily access this. Apart from it, if you have any sort of queries, you can ask. Else, we can close. This is what all I wanted to deliver from my end.
So thank you very much for this very beautiful lecture, sir. I'm really impressed, sir. I understood everything.
Thank you so much. That means a lot to me.
Yes, sir.
So any sort of queries you have, feel free to tag us on Discourse forum. We are there to help you only. No issues with that. Do join in the tomorrow's TA session. It will be helpful for you only. We'll be taking questions from the newer concept. Okay. We'll be taking questions from the old concepts in practice some sort of some exam, so that you can have the last view over the questions which you can encounter in exam. Okay. Chetan, are you there in the meeting? Hello. Chetan, are you there?
Projecting a vector on a number eight.
Okay, I think Chetan is not there in the meeting, so we'll close the recording because I have the host access. Thank you, everyone. Okay, wonderful. So at last 4 लोग बचे हैं जो चारों